Hey, hello guys, welcome back again to my channel. So in this video we're going to be implementing random forest algorithm in Google Colab, and we're going to be using it to predict heart disease occurrence, if someone will, based on some input, if someone will have heart disease or not. And this is the kind of model again that they use in the hospital. So if you are able to do this and you understand everything, so that means you can actually work to develop a model for any clinic, right? So but before we do that, in the last class, right, so we wrote an algorithm for this decision tree classifier, right, and we're able to use it to predict if anybody will survive in a Titanic crash or not, right? So and we can see from our model that we're able to achieve an accuracy of 78.77, right, which is really good. But we also discussed that decision like a random forest is much more accurate than decision tree. Okay, so we want to verify if we implement a random forest for this same thing, if you're going to get more accuracy. Okay, so we're just going to write some more lines of code in here, but before that, let's go and, because our data will be probably off yet, so let's go and import our Titanic data again. So before we do this, so we have that. So let's just close this. So we have our decision tree, so let's import random forest. So in here, just do this and just do this. So this is random forest. You can do it down here too, but it doesn't matter. So let's do that. So we have our random tree right there. So okay, good. So this one is not going to change, this one is not going to change, this one will not change, this one will not change. We don't need to do anything in here. Give me a second, let me check the other screen to make sure that we don't need anything. I think I've run this one. Okay, oh no, okay, so I should run this one once, not twice. So that's an error from my side, so I have to do this again. So this one must be run only once. Okay, then this one will be the same. So now here that we have our decision tree, so we are going to have our random forest too. So let's just put this code in here. So let me go and get the code that I wrote for that. So we're going to have our random forest in here. See, we're going to have our random forest and we're going to train it just the same way that we train the decision tree. So let's do this. Okay, good. Now we have the random forest. So now this one is to predict accuracy for random forest, right? So sorry, for decision tree. So let's create another one just in here. So we're gonna say this prediction is from random tree. Okay, and the model, remember, is this model, not this again. So I'll run this decision tree classifier. Oh, I need to run this. Okay, everything is good. So this is the accuracy report for decision tree, which gave us 78.77. so that's why I can copy all of this, then put another code. Let me just run this again. So this is for decision tree, then for random tree, so accuracy is gonna be, so this is the Y predict for decision tree. So for random tree, it's gonna be this. Okay, than for this one. So let's see the accuracy result. So when I did it before, it was like 90%, but I guess it's improved a little bit, but it's supposed to improve more than this, so like maybe like 90 or something. Let me see what I can, if I can change some parameters in there to see if it will improve the accuracy. So let me do this. So in here, in my model in here, so let me change this to this. So let me do this. Okay, so let me do this. Yeah, you see, so you see, this is the decision, like this is the accuracy from random forest 82%, and this is the one from the decision tree. Okay, so it's just to play around with this, you know, to give you the maximum accuracy, you know, for. But again, we're able to prove that random forest can give us more accuracy than decision tree. Okay, so that's the point. Okay, so now let's now go to the code that we have for today. All right, so we are gonna train our random forest model to be able to identify if someone has heart disease or not, will have heart disease or not. Okay, so we're gonna get our data. So the data, I will put the data in the description, but it's heart.csv heart. Then, like we normally do, we're gonna copy some code, some libraries. So let me just copy all of these. So yeah, we have a lot today. I think some of these ones I didn't even use, like this one. I don't think I used this one, so I'll remove this one. So these are all the libraries that we need, you know, to run our code, and this one is just to ignore warnings. Let's just run that. Everything should be good. Okay, good. All right, so the next thing that we need to do is to load our data and to just see some few values in our data set. Okay, so we should all know this by now. You know, you read your data, then you use the pandas to read it, then you do data.add. Add means that it will give you the first few values, right? So we can see we have age, sex, chest pain type, resting blood pressure, cholesterol level, fasting blood sugar, resting ECG, maximum heart rate, exercise, his all peak, and then the decision to say whether the person will have heart disease or not. All right, so yeah, so that's for that one. So let's go again. The next thing that I want us to do is to just look at the data and see if we have some fields that are empty, right? Because if you have your data point and some of the fields are empty, right, your AI will not work, right? So for example, for this data, let's say that there's nothing in here, right? Your AI would throw error because it needs data for everything. So now this one will just give us information about the data, and this one will give us the number of data point that is empty. So this is null, means that it is nothing, that nothing is in there, right? So let's try that. So we can see this one is null, so it's 0. So all our data point has entries, everything. So our data point is 918 in total, so everything is good. We don't need to do any data cleaning or anything, right? So that's for that one. So then the next thing is just for us to see some graphs, right, of our data set. So we want to see the percentage of people that have heart disease in our data set and the people that don't have heart disease. Okay, so we can see from this graph almost 500 people have heart disease, then 400 they don't have, right? So it's just good to know, right, our that from our data set. So that's for that one. I think we can also have another plot. So this one is called pie chart. So pie chart is just used to show pictorial representation of some data points. So we want to use this to see the percentage. Like this one will give us count of people that have heart disease or not. Then we want to see the percentage in like a cool picture, right? So we can see from here in this picture, people that have heart disease is 55%, people that don't have heart disease is 45% from our data points, right? Again, it's just some cool stuff, you know, to just look at, right? So make sure that you don't make mistake in writing all of this. There's no point in me writing again because of time. So let's go. We are almost getting to the point of creating our model. Oh, then one more thing, we need to have our correlation diagram, right? Show, right? So this one again, it will help you to see what are the things that affect what you are trying to predict more, right? When the number is big, that means it will affect the lot. So we want to predict heart disease. We can see age affected by 0.2, resting BP by 0.11. So that means age affect this heart disease more than this, right? So it's just for us to see. Like now, maximum heart rate is 0.5. Just forget about the sign for now. So that means maximum heart rate will affect the outcome of this more than age, right? So that's how you read correlation data to see how things are being correlated. Okay, so that is that one. So we're gonna start now. So we want to prepare our data for training, and you know we've done this a lot. So we have our data point and we want to predict this, right? So that means we need to put what we want to predict in a separate variable, then remove it from the previous variable. So we're gonna do this, and that is good. So let's see, we're gonna do one more thing. Okay, I want to show something. Okay, so let's just view the data now. So the data is just put X in here. So these are our data. No, it cuts some things off. So we see age, sex, chest type, resting BP, and all of that. So one thing that we see about this is we have some data points that are numbers and some that are text, right? So when you are training your AI, you have to make sure that your data point, they all have numbers, right? So for this one now, we can represent number with 0 and ST with 1 and LVH with 3 or something. So we have to represent all these letters and all these words with something. So this one we can say N will be 0 and Y will be 1. Then for sex, we can say male will be 1 or F is 0, something like that, right? Because the AI is like mathematics, right? It works with numbers. So if you have letters, it might not be effective. Okay, so we have to change all of this to something that the AI will be able to understand, right? And it doesn't make sense for us to change it by hand and say, well, M is 1, F is 0, blah blah blah, or something like that, So there is a cool way that we can do that. That these some packages will help us to figure all of that out. So let me copy this code and put it in here. So it's called encoder, label encoder, and we actually imported it in here, right? That's why we have that. So it's gonna do that for us. So it will help us to encode sex. It will help us to, because sex is MF, it will help us to encode chest pain type, which is this, to some numbers and all of that, right? So let's just run this. So good. Okay, so now let me run it again and just view. So just put X in there and it will show us. So now you see it helps us to turn all this to numbers. So now sex has 1010, chest pain type, which was all these letters, change to this. So now we have all numbers and our AI can work with this. Hope you guys understand that, right? If you have some text in your data point, you have to convert it to numbers, and you can use label encoder to do that. All right, so let's now split our data set into train and test as we normally do. So 0.2 means 80% for train and 20% for test. Okay, hope you guys understand that. So now we have our train and our test data being split into two. So now we need to train our AI model. Let's see. So to train our AI model, we first initialize our random forest classifier. Then this parameter, you can change it, but when you change it, it will either increase or decrease your accuracy, right? So I think this is the best one that I know so far to give us the best accuracy. But yeah, maybe I can give you guys homework to say, you know, change these parameters and see if the accuracy will increase or not, right? So but anyways, we initialize our random forest classifier, and then we train our model based on the X train and Y train data that we extracted from here. So now let's make prediction and accuracy. Okay, so our accuracy, you see, is 89.67, right? So how we calculate the accuracy is, so we predict some values on X, then we compare it with the actual value of that X, right? Then we see how many we got right. So the first homework I want to give you guys is to change these values and see if you can get better accuracy. So for example, if I change this to 20, then I run this and I do this, you see the accuracy reduced. So if I change it to maybe like 50, let's see, and I do this, the accuracy increase, right? Maybe. And if I change it to 100, let's see what we got. The accuracy increase. Okay, so play with this value, then also play with this too. So if I say maybe this one is 10, will it increase the accuracy? It reduces it, right? So play with this and see if you're able to get maybe something like 95 accuracy. So that's for that. So now, like we do before, we can actually view our random forest, you know, because we view our oh yeah, I didn't run it, our decision tree, you know, we can actually view our random forest, right? But the only thing is just that because random forest is a combination of trees, right? So we can only see one tree at a time. So we import this. Then this one is to actually know the number of trees that we use in our forest. This one will tell us the number, right? Then to view a particular tree, you have to say view tree 0 or view tree 1 or something like that. So let's run this. So this is the tree, tree 0, right? But before that, let's see the number of, so we have 100 trees, and I think it's the same thing as this. I think this will determine the number of trees that we have. So we have 100 trees, and this is our first tree. So if you want to check tree 40, this is going to be 49 tree. So you see it's going to look like this, you know, something like that. So just for you to visualize how it's making its decision. Then lastly, yeah, maybe we should even stop there actually. No, let's do some predictions. Okay, let's just give our model some random values, right? No, this is not what I wanted to copy. I copied the wrong thing. Okay, so this one. So you don't have to write all of this, but I just kind of explain this, to let you guys know what all the input means, right? So let's say the age is this, sex is 0, so 0 means female, and chest pain type is 2. Chest pain type 2 means NAP. Like, these are medical terms. I don't know what it means, right? So if you run this now, this one says the person will have the heart disease. Okay, so let me see, because I struggle to get the one that has 0. So let me see this one, 0. Let's say if the age is 40 and it's female, and this is this. Let me copy this somewhere. You know what? So if the age is 40 and the person is male, and this is this. But anyways, I don't want to waste time on that. But my point is, you can find a way to give the model these actual values and see if the heart disease will be 0. Ideally it should be, but I didn't have time to play around this. So play around this, and see if you can get prediction of 0. Then also play around this and see if you can get an accuracy maybe like 95% or more. Alright guys, that is the end of this video. So we're able to implement a random forest classifier in Google Colab using, by the way, like what we've been writing is actually Python programming anyways. I don't know if I've mentioned that to you guys. It's really fun. So very soon we are going to go into much more complex AI algorithm, artificial neural network or deep learning, the one that they use in ChatGPT and all of that, and I think you guys will be able to understand it, right? And the main focus of this is for you guys to learn all of these things, so that when you have anything that you want to work on, maybe you want to create a solution to any problem or anything, the exact AI to use. It might be like problem in your classroom, like maybe like people come to late to school, right? And you want to write an AI that will predict if someone will come late to school or not, right? Or you can write an AI that will predict if a teacher will be good or not, or you can write an AI, to say, based on everything that we've learned so far, like how many students will pass this exam or something, or solve any kind of problem. Like, that's the reason why I'm teaching you this, so that you guys can use it as a tool, to learn, and like for other people too, you can use this to solve any problem, like create a mobile app, put an AI model in it, and sell it to people, right? So I think you guys, I hope that you guys are learning from this and also gaining, a lot from this. All right, that's the end of this video. I'll see you guys in the next video. Bye for now.